In problem 4, we want to throw a rock straight up, and we find out that the rock reaches a maximum height of 100 feet. In this problem, we want to find out what's the initial velocity if the rock reaches a maximum height of 100 feet above its starting point. So we want to find, so we're going to assume that S naught is equal to 0 feet. We're throwing it from the ground. We don't know how high the rock started off, so we'll just go with 0. And what we want to do is find V0. So we know that in this problem, since the rock is only going to be traveling under the force of gravity, it doesn't have any booster jets on the rock. So our acceleration is just going to be, and we're in feet, so negative 32 feet per second squared. Our velocity will be the antiderivative of a of t, so negative 32t plus the v naught we're looking for in feet per second. The information that we have is about a height, 100 feet, so we're going to have to integrate again. Find s of t is negative 16t squared plus v0t, and then we're going to have plus 0 because we're assuming that the rock launched itself from the ground. And what we're going to do is take our sorry, something moved in the background and it caught my attention. So we know that s of t is equal to 100, but that's still so we have a time and a velocity. But we also know at that time, whatever time we get from here, the velocity is going to be 0. So at the maximum height, the velocity is equal to 0 because it stops going up and starts coming down. That's the maximum height is when the derivative is equal to 0. And s of t is equal to 100. So this gives us a system of equations. We get negative 32t plus v naught is equal to 0, and negative 16t squared plus v naught is equal to negative 16t squared plus v naught times t is equal to 100. Let's write that system down. So this tells us that negative 32t plus v naught is equal to 0. And also negative 16t squared plus v0 times t is equal to 100. So we get this system of equations. So we just need to solve our system of equations. So if we solve the first equation for v naught, so we see that v naught is equal to 32t, and I can plug that into the second equation. So plug that in, plugging that in into the negative 16t squared tells us that negative 16t squared plus 32t times t is equal to 100. So this is going to be 32t squared minus 16t squared. That gives us positive. I can make that, messed it up. That tells us that 16t squared is equal to 100. So t is the square root of 100 over 16. There's a plus and minus in the solution to the equation, but we don't care about the minus one. That was before we threw the rock. So we'll have 10 over 4, or 2.5 seconds. So the maximum height, the 100 feet, occurs at 2.5 seconds. We can calculate the velocity at 2.5 seconds. Oh, the velocity is going to be equal to 0. What did we want? Oh, we wanted the initial velocity. There we go, changing what the problem is, right in the middle of the problem. We want the initial velocity, so we know negative 32 times 2.5 plus the v naught is equal to 0. So negative 32 times 2.5 plus v naught is equal to 0. And so v naught is equal to 32 times 2.5. So that's 64 and 16. So is that 80? So that's our initial velocity. Any questions? The second part of this problem says, now imagine being transplanted to the moon and throwing the rock vertically upward with the same initial velocity. So throw the rock up. With the same initial velocity. On the moon. Where gravity is less. Gravity is 5 feet per second. I should say acceleration due to gravity is 5 feet per second squared. So now our acceleration function is negative 5 feet per second squared. Our velocity function is negative 5t plus our initial velocity of 80 feet per second. And so our position function will be negative 2.5 t squared plus 80 t. And we're going to have to assume another plus 0 feet. And in this case, we want to find the maximum height of the rock. So we just want to find the vertex of our height function. We could find that by taking the velocity function and setting it equal to 0 and solving. So the maximum height occurs when the derivative is equal to 0. So I'm going to solve v of t equals 0. So negative 5t plus 80 equals 0 gives us a t of 16 seconds. So instead of just going up 2.5 seconds, now we're going to throw the rock up, and it's going to go up for 16 seconds. Now we can plug the 16 seconds into our height function. And we've gone past the point where I want to do this by hand. I was like all about doing this by hand for a little while, but now I just, no. 640. Any questions? I gotta admit, when I first read this problem, instead of reading it as throw a rock, I read it as throw the rock. And the problem became a lot funnier. But then in the second part, it was just a moon rock. Went back to the first part and said, oh, that's not as interesting. Just a rock. Any questions? Comments? Snide remarks? These two questions, 3 and 4, from this homework assignment are excellent candidates for problems that will show up as quizzes that will collectively make your final. If not both, definitely one of them. So these are good candidates to learn. Any questions, comments, or snide remarks? All right, let's pause the video here.